Okay, so we're simplifying each expression by combining like terms, and what we need to do is be able to identify what is a like term. Okay, so um, if we say, if we look at the first one, 75, 6yz, well, let's talk about which part is the kind of term. And this right here, y times z, that's what the variable set is, y times z, okay? And then 6 is just that's how many of them we've got. Okay, but the thing itself is y times z. Now y will have some value and z will have some value, and y times z will then therefore have some set value, right? And if we say 6 times a certain amount, we can't combine that with something else unless it's also um, of a certain amount. And so this also is y times z. So whatever that number is, if we said y times z is going to produce some number, and we've got 6 of that amount here and then 2 more of that amount, well, that's going to make 8 of that amount, whatever y times z is as an amount. We'll have 8 times that because we got 6 groups of it, then with another 2 groups of it, okay? Then we also, you can see here, this is also y times z. So we're saying, okay, now we've got the instructions to take away 8 groups of that. So we've got 6 groups here of this yz term, 2 more groups of it for a total of 8, and now it says now subtract 8, and that's exactly taking away as much as we have here, and therefore it results in 0. Yep. Okay, so I'll box that as an answer, and let's keep doing that. Let's look at the terms that we've got. So I will just put 0 here as our answer. And keep going. We say, okay, what are the terms that we've got for 77? Well, we've got an m cubed n term. Okay, -9 of them in that one. And here we also have m cubed n. And so those are like terms, okay? M times m times m times n is going to give the same amount here as it does here. Okay, so we can then combine them together and we say what's -9 plus 4? That's -5. And so we have -5 of that m cubed n. But this one, because there's a different amount here, just m times n, that's going to give, if m had a value and n had a value, then cubing m and then multiplying it by n is going to be a different amount than if you just multiply m times n. So this is a different term. We cannot combine those. And so we're going to have to write that separately at the end as just plus 5mn. Okay, sorry for that interruption. So let me box that answer. And hopefully, as you can see, and let me just talk about that one last bit for a second. M cubed n, well, actually, let me write it here. M cubed n. If we picked a value for m, let's say we wanted m to equal, m is equal to 2 and n is equal to 3. Okay? Then if we subbed in those values, 2 to the third times 3, that's going to give us 8 times 3, or 24. Okay? Now, this term, mn, right there, if we were to sub those values in, m is 2, n is 3, and that would result in 6. Okay, so here you're saying -5 times, essentially, if we had those values, it would be -5 times 24, or up top, -9 groups of 24 plus 4 groups of 24. Okay, and then we can talk about, then that means -5 groups of 24. But since it's not, the m is not cubed, this is really only with those values worth 6, let's say, and so you can't say -5 groups of 24 plus 5 groups of 6 somehow cancels out because these are different amounts that you're multiplying by 5 or -5, okay? So you can't just simply say -5 plus 5 because it's not just a -5 as a constant. It's a coefficient of this number, and this number has a different value than this number has. So we can't say -5 of these is canceled out by +5 of those, not the same value. Okay. Hopefully that I over-explained that, and rather than you not really understanding it. So anytime you're looking at the variable set and the exponents are different, even if the letters are the same, if the exponents are different, they become different terms. So finishing this out, we say, okay, for 79, 79, we need to identify what are the like terms, and I'm going to underline them in different colors. Okay, so here we have x squared y. Remember, that's different than x squared y squared because the exponents are different. So do we have any more x squared y's? Yeah, we do actually, x squared y down here. Great. What else we got? Well, we've got an x squared y squared. Do we have any more x squared y squareds? No, we actually don't. These all have different amounts of x and y. X cubed, y squared is not the same. And in fact, x cubed y squared, there's only one of those. And going further, x y squared, that's also different. Okay? One last time. The variables not only have to be the same variables, but they have to be raised to the same power in order to be able to be considered like terms. So the only things that we have are like terms are this x squared y and this x squared y. They're the same. So we can say 12 of those x squared y's plus 11 of them is 23 x squared y. Okay, so everything else we need to just continue to write. There's no matches for this -8 x squared y squared. There's no other terms, that same term, so we just have to write that as -8 x squared y squared. Same thing for this one. There's no other term that's an x cubed y squared term, so we say -4 x cubed y squared. And finally, there's no other matching x y squared term, so we just have -9 of those x y squared terms. And that is the answer. The only thing you were able to combine in that one were these two parts that were both x squared y terms. And that was a good one to illustrate, to really see, oh yeah, they all have quote unquote and x's and y's in them, but different amounts of x's and y's, so that changes it, makes them different terms.